Hello, everybody. We are continuing forth with our lesson on logarithms, exponential functions, and logarithmic functions. This is a continuation from yesterday. So you should have some notes that you can follow along with. If you haven't printed those out, print them out right now. Pause the video and come back so that you can fill in the notes with me. So, okay. Recall that a common logarithm, and it's called common because it's commonly used, has base 10. Common logarithms have base 10. And instead of writing out log of base 10 of x, because it's used so commonly, we just write log of x. So if you do not see a base written here, no base with a log means base 10. It's kind of like when you write a positive number, you don't need to put a plus sign in front of it, but when it's negative, you do need to put a negative sign in front of it. So anyway, the next piece here, natural logarithms have base e. Recall that e is the number approximately 2.72, and instead of writing the log of base e of x, we just write ln of x, ln standing for natural logarithm. So if you see a logarithm without a base and then instead of log it says ln, you'll know that the base is e. So let's look at how to work with some of these logarithmic properties. We have log of base 2 of 8. So the base is 2. And in your calculator, you can't evaluate this because your calculator only has base 10 and base e, so the common logarithm or the natural logarithm. So when you have a base other than 10 or e, you're either going to need to be able to evaluate it without a calculator, or you're going to have to do a change of base, which we'll get to in just a minute. But here we have the log of base 2 of 8, and we're trying to figure out what that equals. Remember, a logarithm is an exponent. And so if we rewrite this in exponential form, I'm not sure what the exponent is, so I'm going to write 2 to the x. So if it's going to equal something, so we can say it's going to equal x. And now we're going to figure out what x is. So 2 to the x equals 8 is how we could rewrite that into exponential form. And then what, okay, so trying to evaluate log of base 2 of 8, we're looking for 2 to what power equals 8, and it would be 3 because if you take 2 to the third power, it's 2 times 2, which is 4, times another 2 is 8. So this one we can do without a calculator. Let's look at the next one here. We've got a log of base 2 again of 32. So we're trying to figure out 2, we're looking at 2 to what power, you can put a question mark even, or you could put in a variable, is equal to 32. And the answer is, of course, 5, because 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times 2 again is 32. So since 2 to the 5th is equal to 32, the answer to this, to simplify log of base 2 of 32, it would equal 5. So the next one is log of 100, and there's no base written there. So what does that mean? Well, it means that the base is 10. When there's no base, recall that the base is 10. So we're looking for 10 to what power is equal to 100. And so all of these so far can be done without a calculator. That's going to equal 2 because 10 squared is 100. And then ln of e, recall that that has a base of e because we have ln with no base written there. So we're looking for ln of e, and so this little base, if we rewrite that in exponential form, we have e. My computer is not cooperating. So we have e to the what power, because this little base right here is an e. It's not written there, but it's there. E to the what equals e. E to what power equals e. Again, when we're evaluating a logarithm, we're looking for the exponent. So this would be e to the first, because e to the first would equal e. Okay, so I'm going to stop there, and then we'll get into the properties of logarithms in the next video.